Hello everyone. Now we will study about vector calculus. So first of all we have to know what is a vector. Then a vector is a quantity that has both magnitude and direction. Now take a line segment AB whose initial point is A and terminal point is B and its direction is from A to B and it is denoted by vector AB. Now some properties of vector. First, the magnitude or length of vector AB is denoted by mod AB vector, which is known as norm of AB. Second, a vector whose magnitude is unity is called unit vector. Third, two vectors are said to be equal if they have same magnitude and the direction. Fourth, representation of vector is equal to magnitude of a vector into unit vector in the direction of vector. Fifth, the unit vector in the direction of vector A is A vector upon mod A vector. Last, addition of vector. Now take two vectors A and B. Now the line segment opposite to A and B line segment, which is A plus B. This is called triangle law of vector addition. Now vector in R2. Let P x comma y is a point in R2 and I j to the unit vectors in the positive direction of x-axis and y-axis respectively. Now from the diagram we can see that vector OA is x I cap and vector AP is equal to y j cap. OP vector is equal to x I cap plus y j cap from the triangle law of vector addition. Now OP vector is equal to OA vector plus AP vector, which is equal to x I cap plus y j cap. Mode of OP vector is equal to under root x square plus y square. Take point P1 and P2. P1 is equal to x1 comma y1 and P2 is equal to x2 comma y2. P1 P2 vector is equal to x2 minus x1 I cap plus y2 minus y1 j cap. Therefore, P1 P2 vector mode is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. Vector in R3. Let P x comma y comma z be a point in R3 and x and I cap comma j cap k cap be the unit vector in the positive direction of x-axis, y-axis and z-axis respectively. Then OP vector is equal to x I cap plus y j cap plus z k cap. Now P1 and P1 point is x1 comma y1 comma z1 and P2 point is x2 comma y2 comma z2. Then mode of OP vector is equal to under root of x square plus y square plus z square. P1 and P2 vector is equal to x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Mode of P1 P2 vector is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now we will learn about dot product of vectors. Let us take vector u, which is equal to u1 I cap plus u2 j cap plus u3 k cap, and vector v, which is equal to v1 I cap plus v2 j cap plus v3 k cap. Then their dot product is denoted by u vector dot v vector, which is defined as u vector dot v vector, which is equal to v1 u1 plus u2 v2 plus u3 v3. Example, let u vector is equal to minus 3 I cap plus 2 j cap plus k cap and v vector is equal to 4 I cap minus j cap plus 2 k cap. Then dot product of u vector and v vector is equal to minus 12 minus 2 plus 2. Then by solving we will get minus 12. Now take another example. Then u vector is equal to 4 I cap minus j cap plus 3 k cap and v vector is equal to minus I cap minus 2 j cap plus 5 k cap. Then dot product of u vector dot v vector is equal to minus 4 plus 2 plus 15 is equal to 13. Now the some properties of dot product of vectors are, first is u vector dot u vector is equal to mode of u vector square. Second is u vector in dot v vector is equal to v vector dot u vector. Third, two vectors u vector and v vector are orthogonal if u vector dot v vector is equal to 0. So I cap dot j cap is equal to j cap dot k cap is equal to k cap dot I cap is equal to 0. Now determine which pairs of the following are orthogonal. Then u cap is equal to 3 I cap plus 7 j cap minus 2 k cap, and v vector is equal to 5 I cap minus 3 j cap minus 3 k cap. W vector is equal to j cap minus k cap. Now we will solve it. Then we get that u vector dot v vector is equal to 15 minus 21 plus 6, which is equal to 0, and v vector dot w vector is equal to minus 3 plus 3, which is equal to 0. Then u vector dot w vector is equal to 7 plus 2, which is equal to 9. Then by solving these three dot products, we get that u vector dot v vector is equal to 0 and v vector dot w vector is equal to 0. Therefore they are orthogonal. So u vector and v vector are orthogonal, and v vector and w vector are orthogonal. Now we will learn about cross product of vectors. Let u vector is equal to u1 I cap plus u2 j cap plus u3 k cap, and v vector is equal to v1 I cap plus v2 j cap plus v3 k cap. Then their cross product is denoted by u vector cross v vector, which is equal to determinant of u1 u2 u3 v1 v2 v3. Therefore now we get some properties. So first property is u vector cross u vector, which is equal to 0. Second, u vector cross v vector is equal to minus of v vector cross u vector. So I cap cross j cap is equal to k cap, comma j cap cross k cap is equal to I cap, and k cap cross I cap is equal to j cap. Now we will learn about vector functions. Then a vector function f of a real variable t is a function of the form f vector t is equal to f1 t I cap plus f2 t j cap plus f3 t k cap, where f1 f2 f3 are real valued functions of a real variable t. f1 f2 f3 are component functions of f vector. f1 belongs to R2R, f2 also belongs to R2R, and f3 also belongs to R2R. Now example of f vector t is equal to t I cap plus t square plus 1 j cap plus sin t k cap. Now some properties of vector functions. Let f vector and g vector are two vector functions of real variable t. Then f vector plus g vector t is equal to f vector t plus g vector t, and f vector minus g vector t is equal to f vector t minus g vector t. F vector dot g vector t is equal to f vector t g vector t. F vector cross g vector t is equal to f vector t cross g vector t. Then phi f vector t is equal to phi of t f vector t. Here phi isn't scalar function. Now example given ft is equal to 2t I cap minus 5 j cap plus t square k cap, and g vector is equal to 1 minus t I cap plus 1 upon t k cap, and h vector is equal to sin t I cap plus e power t j cap. Now we have to find f vector t dot h vector t cross g vector t. Now first of all we will find h vector t cross g vector t, which is equal to determinant of sin t e power t 0 1 minus t 0 1 1 by t, which is equal to e power t upon t I cap minus e power t sin t upon t j cap minus e power t 1 minus t k cap. Now we will find dot product of f power t f vector t dot h vector t cross g vector t, which is equal to 2t into e power t upon t plus 5 e power t sin t upon t plus 2 plus t square e power t 1 minus t. Now limit of a vector function. Let f vector t is equal to f1 t I cap plus f2 t j cap plus f3 t k cap. Now we have to find limit t tends to t node f vector t. Then if limit t tends to t node f1 t comma limit t tends to t node f2 t comma limit t tends to t node f3 t exists, then limit t tends to t node ft also exists. Therefore limit t tends to t node ft is equal to limit t tends to t node f1 t I cap plus limit t tends to t node f2 t j cap plus limit t tends to t f3 t k cap. Then some examples. Evaluate the following limit t tends to 1, t cube minus 1 upon t minus 1 I cap plus t square minus 3t plus 2 upon t square plus t minus 2 j cap plus t square plus 1 e की power t minus 1 k cap. Then we will find first limit t tends to 1, t cube minus 1 upon t minus 1 is equal to limit t tends to 1, t 3t square upon 1, which is 0 by 0 form, and by L'Hopital rule we get limit t tends to 1, 3t square. Then limit t tends to 1, t square minus 3t plus 2 upon t square plus t minus 2, which is equal to limit t tends to 1, 2t minus 3 upon 2t plus 1, which is also 0 by 0 form, and h or. Then we will apply L'Hopital rule. Limit t tends to 1, t square plus 1 into e power t minus 1, which is equal to 2, e power 0 is equal to 2. So the final answer is 3 I cap minus 1 by 3 j cap plus 2 k cap. Now some properties of limit vector. Then let f vector and g vector be vector functions. Then first we get that limit t tends to t node f vector cross g vector t, which is equal to limit t tends to t node f vector t plus limit t tends to t node g vector t. Then second, limit t tends to t node f vector dot g vector t, which is equal to limit of t tends to t node f vector t limit t tends to t node g vector t. Third, limit t tends to t node f cross g f vector cross g vector t is equal to limit t tends to t node f vector t cross limit t tends to t node g vector t. Fourth, if phi is a scalar function, limit t tends to t node, then phi vector f t is equal to limit t tends to t node phi t into limit t tends to t node f vector t. Then we will solve example. Given then f vector t is equal to t I cap plus t square j cap plus t cube k cap, and g vector t is equal to 1 upon t I cap minus e power t k cap, j cap. Verify that limit t tends to 1 f vector dot g vector t is equal to limit t tends to 1 f vector t dot limit t tends to 1 g vector t. Then from LHS we will find f vector dot g vector t is equal to 1 minus t square e power t. Then limit of t tends to 1 f vector dot g vector t is equal to 1 minus e. Then RHS limit t tends to 1 f vector t is equal to I cap plus j cap plus k cap. Then limit t tends to 1 g vector t is equal to I cap minus e power j cap. Then limit t tends to 1 f vector t dot limit t tends to 1 g vector t is equal to 1 minus e. Therefore LHS is equal to RHS. Then continuity of vector function. Let f vector is equal to f1t I cap plus f2t j cap plus f3t k cap be a vector function. Then if the component functions are continuous at t node, then the vector function f is continuous at t node. Example, determine all values of t where the vector function is continuous. First, f vector t is equal to sin t I cap plus 1 upon 1 minus t j cap plus cos t k cap. Then f1t is equal to sin t, which is continuous in f2t is equal to 1 upon 1 minus t, which is continuous in r minus 1. f3t is equal to log t, which is continuous for t greater than 0. Therefore f vector is continuous in 0 comma infinity minus 1. Then another question, g vector t is equal to u vector upon mode of u vector, where u vector is equal to t I cap plus under root t j cap. Then g vector t is equal to t I cap plus under root t j cap upon under root of t square plus t. Then g vector t is continuous in 0 comma plus infinity. Then we will find differentiability of vector functions. Let f vector t is equal to f1t I cap plus f2t j cap plus f3t k cap be a vector function. If the component vector functions f1, f2, f3 are differentiable at t node, then the vector function f is differentiable at t node, and f vector t node is equal to f1 dash t node I cap plus f2 dash t node j cap plus f3 dash t node k cap. Example, for what value of t is f vector t is equal to mod of t I cap plus cos t j cap plus t minus 5 k cap differentiable. Then f1t is equal to mod t, which is differentiable in r minus 0, f2t is equal to cos t, which is differentiable in r, and f3t, which is equal to t minus 5, which is differentiable in r. Therefore f vector is differentiable in r minus 0. Then example, differentiate the scalar function fx, which is equal to xi cap plus x plus 1 j cap dot 2x I cap minus 3x square j cap. Then we will solve it. Then fx is equal to x into 2x plus x plus 1 into minus 3x square, which is equal to 2x square minus 3x cube minus 3x square. Then by solving we get minus x square minus 3x cube. Then f dash x is equal to minus 2x minus 9x square. Some properties of differentiability of vector function is, now let f vector and g vector be vector functions. Then first, f vector plus minus g vector dash t is equal to f vector dash t plus g plus minus g vector dash t. Second, f vector dot g vector dash t is equal to f vector dash t dot g vector t plus f vector t g vector dash t. Third, f vector cross g vector dash t is equal to f vector dash cross g vector t plus f vector cross g vector dash t. Fourth, phi f vector dash t is equal to phi dash t f vector t plus phi t f vector dash t, where phi is scalar function. Now we will do the last example. If f vector t is equal to 3 plus t square I cap minus cos 3t j cap plus 1 upon t k cap, and g vector t is equal to sin 2 minus t I cap minus e power 2t k cap, then verify f vector dot g vector dash t is equal to f vector dash g vector t plus f vector dot g vector dash t. Then f vector dash t is equal to 2t I cap plus 3 sin 3t j cap minus 1 upon t square k cap. G vector dash t is equal to minus cos 2 minus t I cap minus 2 e power 2t k cap. Now by solving from LHS, f vector dot g vector t is equal to 3 plus t square sin 2 minus t minus 1 upon t into e power 2t. Then f vector dot g vector dash t is equal to 2t sin 2 minus t plus 3 plus t square cos 2 minus t minus 1 upon t square e power 2t minus 2 upon t e power 2t. Then from RHS, f dash vector dot g vector t is equal to 2t sin 2 minus t minus e power 2t upon t square. Then f vector dot g vector dash t is equal to minus of 3 plus t square cos 2 minus t minus 2 upon t e power 2t. Then f vector dash dot g vector t plus f vector dot g vector dash t is equal to 2t sin 2 minus t minus 3 plus t square into cos 2 minus t plus e power 2t upon t square minus 2 upon t e power 2t. Therefore LHS is equal to RHS. Thank you.